So in this problem we have a truck pulling a 1400 kilogram car, and the rope cannot exceed 2500 newtons until it breaks. So we know that F equals 2500 newtons. We know the car equals 1400 kilograms, and so that makes that F equals ma. So 2500 newtons equals 1400 kilograms times acceleration. So to find the acceleration, we divide 2500 newtons by 1400 kilograms and get 1.78 meters per second squared is the maximum that the truck can accelerate before the rope would break. In part 2, we had to find the maximum force that the rope had to withstand in order for the truck to accelerate at a given velocity. So we know the initial velocity was 0, the final was 32 meters per second. The time it took to get there was 2.7 seconds. We don't know the acceleration and we don't know the force, so we know that the acceleration would be the final velocity minus the initial velocity divided by the final time and the initial time, which gives us 11.85 meters per second squared. So then we're looking for the force. So we know that the weight is 1400 kilograms. We multiply that by 11.85 meters per second squared, and that gives us that the rope would have to withstand 16,590 newtons in order for the truck to accelerate at 11.85 meters per second squared. And then in the final problem, we had a car being lifted by a lift, same car, at a acceleration of 3.56 meters per second squared. And we know the car is 1400 kilograms. So the force equals the weight of the car times the weight of gravity, but we have to add the acceleration of the lift. So once we do that and then multiply that by 1400 kilograms, we get 18,704 newtons as the force of the lift on the car as it moves out.